Good morning, guys. Welcome again in our math class on its third week. And today we're going to discuss about the absolute value and integers. But before that, let's have discussed the first thing that we have to know about the absolute value and the integers. First is the absolute value and number line. Absolute value and number line. It says here that the absolute value of a number line as indicated here with two vertical lines from left to right and with a small n number. It is the distance of the given number on the number line from 0. The absolute value of a number disregards directions from where it lies with respect to 0. When we talk of distance, it is always positive. The absolute value of 2 written as written here, the absolute value of 2. So assuming this is the n, we replace it with 2 because we are referring to the value, the absolute value of 2. Represents its distance from 0 to the number line. So what is the number line, Sebs? Number line is the number or the lines consisting of integers, as shown here at the bottom part. Integer number line or the number line of an integer or integers. Let's take a note on this, guys, that the number line are with numbers from the right of 0, such as the 1, 2, 3, 4, and to its left are the following: -1, -2, -3, -4. All numbers you found from 0 to its right are so-called positive integers. So the following number here, including 1, 2, 3, and 4, are positive integers, and its count continues because of the arrow directing to the right of zeros. It counts more and more. While on the other side of 0, all numbers that we've found from its left is so-called as the negative integers. Yes. And here are the negative integers. From the left of 0 is -1, -2, -3, and -4. These are the negative integers. Take note that the negative integers are all numbers you found from the left of 0 or 0 to its left. And it's counting too because of the arrow directing to left of zeros, from zeros. And take note that the 0 is neither positive nor negative because 0 is neutral. It has no sign. 0 is neutral. So to summary that about the absolute value, it says here that the absolute value is always positive. Absolute value refers to distance. That's right. How can we describe distance pertaining to absolute value? So in the first example, or the absolute value above here, the absolute value of 2 is written as this one. How can we refer that the absolute value of 2 is is linked with distance or defined by distance. So as you can see here, this is 2. So if we're going to define the absolute value of 2 by the word distance, we could say that the distance covers from 0 to positive 2 because it refers on the absolute value of positive 2, because 2 is on the positive sides of integers. So we could say that we can cover certain unit distance from 0 to 2. And we're going to count the distance covers from 0 to 1 from 0 to 1 and 2, we could mark it and we can place the distance unit from 0 to 2. So from 0 to 1 there is 1. From 1 to 2 there is 1. We're going to count the distance units covers from 0 to 1, it is 1, and another one from 1 to 2, it is 1. We're going to count it one by one. From 0 to 2, there is 2 unit distance because because there is one count unit from 0 to 1 and another one from 1 to 2, 1 unit distance. So that is why the absolute value of 2 is equal to 2 units. 2 units. 2 units because from 0 we cover 2 distant unit to 2 here. Since positive integers has opposite side or opposite numbers with refers to sign. Because positive integers has the sign just like this one, the plus sign. And the negative integers has this one, negative sign. So if we're going to count the distance covered from 0 to negative 2, going to left of zeros, the same process we've used here in positive integer is the same here. We're going to take place. So from 0 to negative 1, there is 1 unit cover. And from negative 1 to negative 2, there is another 1 unit distance cover. So if we're going to count it in whole, from 0 to negative 2, there is 1 plus 1 is 2, or it has 2 unit distance. 2 unit distance. So we could say that the absolute value of negative 2 is just the same with the absolute value of positive 2. Why is that so? Because it's written here or it's given here that when we talk about distance, it's always positive. So that is why there is no such negative distance here. So meaning to say, the absolute value of any integer is or has equivalent of positive integer or positive distance unit represented by integers. In other words, or in general, any integer such as positive, negative, inside the absolute value or the absolute value of any integers is equal to a positive integer. So it's written here that the absolute value of positive or negative integer is equal to positive integer. Says here, para maunawaan ng iba, ang absolute value ng anumang integer sa loob nitong absolute sign o absolute value sign ay may katumbas na positive integer. So that is why please take note on this part because there were more things we know about the absolute value. But the first thing that we must bear or put in mind that the absolute value of any integer, mapapositive man siya o negative, has an equivalent positive integer. So let's move on. Let's go on the next part. The next one is the examples of the absolute value and the number line. Let's have the illustrative example 1 and 2. Illustrative example 1 and 2. So, on example 1, we are asked to represent absolute value of 6. The absolute value of 6 here. So, as we remember, the absolute value is repressed to distance from 0. So as you can see here, it is positive 6. There is no such sign of negative or positive. But automatically, later, we're going to take note on the positive or negative numbers or integers. So if you don't see any negative sign here, it's automatically positive integers. So it says here the absolute value of 6, and we're asked to find the absolute value of 6 on the number line. So we're going to count from 0 going to the right. So we're going to place the integer 6 or the number 6 here. So it marks this one. It marks. So we're going to find the distance units covered from 0 to 6. There is 1, 2, as the same as this one, 2, 3, 4, 5, and 6. So the distance covered from 0 to 6, or the absolute value of 6, is 6 units distance. So it's here. The absolute value of 6 is 6 units from 0. Kung makikita niyo po yan, ayan po, bibinilang na po natin. 1, 2, 3, 4, 5, and 6. It does. The absolute value of 6 is 6. That is in symbols. So, inunit na lang po natin. Ayun po yun. On illustrative example number 2, we're asked to represent the absolute value of negative 4. Take note, it is negative 4. So, meaning to say, the directions that we're going through is from 0 to its left. So, we're going to mark the negative 4 here for us to guide. So, from 0 here, we're going to count the distance unit covered from 0 to negative 4. We have 1, 2, 3, 4. So, it says here that the distance of the negative 4 from 0 is 4 units. So, as the same as this one when we count the... So, the same as this one when we count the distance from the 0 to 6. So let's proceed. The next example, or the illustrative examples for number 3 and number 4 are these. For illustrative example number 3, we are asked to represent the absolute value of negative 5 plus the absolute value of 3 on the number line. So there were two absolute values here. So it is advised for us to take it one by one. So let's take first the absolute value of negative 5. Okay, so we're going to locate the negative 5 from 0. We're going to mark it. So the negative 5 is found here. So we have marked. And we are asked to find what is the absolute value of negative 5. Or shall we say, what is the distance covered between 0 to negative 5. So let's count it. 1, 2, 3, 4, 5. So meaning to say there were 5 unit distance covers 5 unit distance covers from 0 to negative 5 because as we say that the absolute value is refers to distance and there is no such negative distance for absolute value or if we are talking about the absolute value. So let's see, we have 5 here. The absolute value of the negative 5 is 5. And how about the absolute value of 3? So in the same process, we're going to locate or mark the positive 3 and it's on the right side of 0. So we're going to count the distances cover or the distance unit cover from 0 to 3. So we have 1, 2, and 3. So meaning to say the absolute value of 3 is equal to 3. The same equal to 3. The same concepts on the distance units covers from 0 to 3. So if we are asked to find what is the distance covered from 0 to 3, it is 3 distant unit or 3 unit distance. So that is. So after the representations of the absolute value of negative 5 and 3, we're going to count the total of the absolute value of negative 5 and the absolute value of 3 because we are referring to additions. So that is why in total, in sum up. So we have 5 to the absolute value of negative 5 and take the plus sign and we have 3 here as for the absolute value of 3. So as shown here, it is equivalent to 5 plus 3 and the answer is 8 as shown here. So meaning to say the distance covers from negative 5 to 0 is 5 and the distance covered from 0 to negative to positive 3 rather is 3 and all in all the distance covers from negative 5 to positive 3 is 8 unit distance. So for other examples here, this more typical or typical questions here because as we define the absolute value, it says here that any integer such as positive or negative integer, call say we, we say it integer n inside the absolute value has a unique or has a positive integer equivalent for any integer. But in here, aside from negative 5 integer inside the absolute value sign, on its outside there is a negative sign. So firstly, we have to take it one by one on the absolute value first. We already know that the absolute value of negative 5 is 5. But take note, guys, there is negative sign outside the absolute value. So that is why instead of 5 only, we're going to take place the negative signs outside the absolute value and be paired to 5. So that is why the answer for the illustrative example number 4 is equal to negative 5. So it says here, when a negative sign appears before the absolute sign, this will mean you are taking the inverse or opposites of the absolute value, thus leading to a negative numbers. Don't be confused on the properties of the absolute value. It says here on the previous and on the upper part that in general for every integer inside or for every number inside the absolute value there is there is a positive number. Some would say it they write it as this one for this as the same concepts in general for the integers. We are talking about integers. Letter Z, small z. Sorry for the capital Z, but it is small z. For every integer inside the absolute value, there is a equivalent positive integer, just the same as this one. So, as you can see here, it goes negative 5 as the answer for the illustrative example number 5. So, let's proceed on the next part. Okay, the next part is how to add or the additions of integers, and we are asked to the process on how to add integers. So when we talk about integers on the latter part, there were positive and negative integers, including zeros as neutral. So in here, in addition of integers or in adding integers, there were two rules that we have to abide or follow. The first one is to add integers with the same sign. All you have to do is to add their absolute value and use the common signs of the sum. Absolute value. On the first example here, 3 plus 2 is can answered by your own because 3 plus 2 is automatic 5 as we count it one by one. So, but take note here that some would repair 3 here as positive 3 plus positive 2 be equal to positive 5. It answered our first questions a while ago that we're going to discuss because in just in case that there were integer with no sign of negative, it is automatically positive integer. Take note that the sign for integer is z. So as you can see here, the definitions that I'm trying to employ to you. An integers with no negative sign is automatic a positive integer. So that 5 is a positive integer. So if there is no such negative sign, these numbers are positive integer. So in here, no problem with this one. On the second example, negative 3 plus negative 2. So aside from adding integers of usual numbers we add, there were signed integers or negative signed integers, and we're going to follow the first rules. Negative 3 plus negative 2 equals what? So it says here we're going to add their absolute value. So that is why we rewrite negative 3 to absolute value of negative 3. Absolute value of negative 3. And the negative 2 is on the absolute value of negative 2. So the this rules takes place because we take the absolute value of these two integers. So the absolute value of 3 is 3 because as we define, for any signed integers, for any integers inside the absolute value has positive integer equivalent. So from negative 3, we're going to have positive 3. Take note, for any integer that with no negative signs, it is automatically positive integer. So there, assuming that there is a invisible positive sign on the upper part. So let's see. Positive 3 plus positive 2 equals 5. But then again, it says here that the common signs must take place. We're going to copy the common signs. On the original part of the mathematical equations, there is negative sign in common. So that is why, according to here, the common signs must take place. The common signs of the sum. And that is the negative. So instead of positive 5, we have negative 5 because we take place the common sign. We employ the common sign. And on the second part, to add integers with different sign, subtract their absolute values. The result has the sign of the integer with greater absolute value. So take note, in subtracting their absolute value. To add integers with different signs, we have to subtract their absolute value. The result has the sign of the integer with greater absolute value. So let's see this. 3 plus negative 2. 3 plus negative 2. So we're going to take the steps here. We're going to take the absolute value of each integer. The 3 for the absolute value of 3. And the negative 2 for the absolute value of negative 2. So in here, since they are in different sign, one is negative and one is positive, as I mentioned a while ago. So instead of adding the integers, we're going to subtract it because they have different sign. So 3 minus 2 is equal to positive 1. Positive 1. So is it positive 1 is already the right answer? Yes, because the positive 1 is already the right answers. We can rewrite the positive 1 as 1 only So it is 1 only because it says here that the result has the sign of the integer with greater absolute value. So the value of the sign of the greater absolute value is positive here. So as you can see here, this one, this we're going to mark it for us to see. The value of absolute positive 3 is positive. The value of the absolute value negative 2 in its sign rather is negative. So when we take the difference of 3 and 2, it is equal to 1. So we're going to employ the sign of the integer with the greatest absolute value. And the greatest absolute and the sign of the greater absolute value integer is positive. So that is why the answer is positive 1. Take note that the positive 1 can rewrite as 1 only because it says here an integer with no negative sign is automatic a positive integer. And on the second part is that negative 3 plus positive 2. So we must take place the absolute value of an integer. So the absolute value of negative 3 for this one and the absolute value of 2 for this. So since they are in different sign, one is negative and automatic this is a positive integer. Instead of adding, we're going to take the difference. We're going to subtract it. So 3 minus 2 is 1. So that is the answer. But the question is, but the sign of integer with greater absolute value is negative. So as you can see here, the negative 3, when we take the absolute value, it is positive 3. And we take the absolute value of 2, and that is 2. And the sign of the greater absolute value is negative in original. So that is why instead of positive is the sign of our answer for this mathematical operations and equations, we take negative 1 as the final answer for negative 3 plus 2. So thus, negative 3 plus 2 or negative 3 plus positive 2 is equal to negative 1. So the sign of the integer with greater absolute value is employed and take place. So let's proceed. The next one is, or the next or the last part is how to subtract integers. Okay, subtraction of integers is just the same way on adding integers, but we must take with two certain rules. We must abide with two certain rules. So the first one is decay. We're going to keep the first element or the first numbers or integers. The C stands for change the subtraction sign to addition sign. O stands for opposite sign of the next number must take place. So for us to understand this and to prove that this is just the same with adding integers, so let's take the rules on subtracting integers. So it says on the above rules, we have to keep the first integer. as you can see here, keep, we just copy. We just copy the first integer. And the next one is change the subtraction sign to addition sign. As you can see here, we change it. And for the third part is take the opposite sign of the next number. So as you can see here, it is negative 2. It is negative 2, so that is why it must become positive 2 or 2 only. Take note that there is a negative, a invisible positive sign here. So we're going to read it again. The negative 3 minus the quantity of negative 2. Take note for this, for those who are new for this, we read it as the quantity of negative 2 or the opening close parenthesis, but it would be better to read it as the quantity, because later on we're going to use this for you to understand the terms and concepts we're going to use starting today. So negative 3 minus the quantity of negative 2, the the three steps here must take place. So keep change opposite. So negative 3 plus, instead of subtraction, it must be plus sign, and instead of negative 2 it would be positive 2. So in here, as would I say, just the same with adding integers, and here they are. So the next part is to take the absolute sign of every integer. Negative 3 is for the absolute value of negative 3, then copy the plus sign. And the absolute value of 2, that's it. As you can see here, follow the rules of adding integers. So the absolute value of negative 3 is 3. Okay. And it says on the adding rule of integers, the plus sign must be rewrite or changed into subtraction sign. Instead of adding, we're going to subtract. And the absolute value of 2 is 2. So it's just the same as the rules on adding integers. So 3 minus 2, it became 1. But the question is this. As the same rules we've used on adding integers, what is the sign of original integer on absolute value? It is negative. So, so and this part is positive. So the sign of the greatest, or the sign of the integers with greater absolute value is negative. So that is why instead of positive 1 is the right answer. The sign of the integer with greatest or with greater absolute value must take place, and that is why the answer is negative 1. Thus, the 3 negative 3 minus the quantity of negative 2 is equal to negative 1. And it says here, since the sign of integer with greater absolute value is negative, negative rather, the sign must be negative. So it's negative 3 minus the quantity of negative 2 be equal to negative 1. So let's proceed on the next sample for subtractions of integers. Negative 9 minus 4. Negative 9 minus 4. The 4 here is positive integer. So as you remember, for any integer with no negative sign, it is automatic positive. So the rules on subtraction of integers must take place. So we have keep, change, opposite. So we have to keep negative 9. rewrite or copy. And the plus sign, the minus sign here would become plus sign because we changed it. And the positive 4 here became negative 4. So as you can see here, follow the rules of adding integers, just the same with this one. So take the absolute value of negative 9, the negative 9 absolute value, plus, copy, and the absolute value of negative 4. Take note this, guys. These two integers are in with common sign. They are negative. They are both negative integers. So that is why on rule 1 of adding integers must take place. So the absolute value of 9 is 9. The absolute value of negative 4 is 4. So it's just the same with 9 plus 4. It is 13. And and the rules adding integers with common signs, on common signs such as for positive and negative, we must take place those rules. So that is why the common signs for the negative 9 and negative 4 must recopy. So instead of positive 13 is the answer. The negative sign for the operations must take place. And and it says here, hence the common sign is on this part is negative. The sign of the answer must be negative 13 so that negative 9 minus 4 is equal to negative 13. So, as I would say, subtracting of integers is just the same on the concepts used and on the rules of adding integers. Only on subtracting integers, we must take place with these three rules. Keep change opposite. Keep the first number, change the subtraction sign to addition sign, and opposite sign of the next number must take place, or we have to change the sign of the next number. If it is positive, we must take it negative. If it is negative, we must take it on negative numbers. So that is for the addition and subtraction of the integers as well as for the number line and the absolute value. So those terms are very useful, and the concepts of the absolute value and the number line are very useful in understanding the concepts of adding integers and subtracting integers. So let's proceed. So for your task, you're going to answer learning task 1 on page 13 on your modules. On a separate sheet of paper, illustrate a sea with the following: a crab 5 feet below sea level, a cliff 3 feet above the sea level, and a flying bird 4 feet above sea level. Use a vertical line number to help you out in the illustrations. So guys, instead of horizontal number line, you're going to use vertical number line. Vertical number line. The one that I shown you or shared you, number line is horizontal. So you're going to use the vertical number line. The same concepts, only it is vertical. After making the drawing, study it carefully and answer the questions below. What number might be a good representation of the sea level? So as you remember, there is no such negative So as you remember, there is no such negative distance. So the knowledge about the horizontal number line of an integer is very useful here. So you're going to represent this you're going to represent this on number line on the vertical number line, and you're going to answer this. How to represent the distance below and above the sea level? How far is the cliff from the sea level? And how far is the bird from the sea level? All these questions are asked about the distance unit cover from the sea level. Let's say that the sea level is the midpoint or the in between. Let's say it is 0. So that is your first clue. Let's the sea level is on the neutral or on the middle part. But if there is any representations of the numbers, it would be better to use for us the sea level must be on the middle part. Next is on the learning task 2, page 16, you're going to do this. You have 10 questions or 10 mathematical questions here or mathematical equations here for additions and subtracting the integers. So in adding integers, you have to follow the two rules. Let's do this. Let you have do this for you to master or for you to master and not just be familiarized with the rules and be able to answer the ways on how to subtract integers on the set B. So please take note on the lessons or discussions we have taken up. And the learning task 3, you're asked to solve each problem involving integers. So it's just the same on the concepts we've used and we've studied. And only there were materials given here, one for the mercury thermometer. And I know you are familiar with this, lalo na yung mga ate at kuya nyo na may mga ATM, ayan. O di kaya, card key number, ayan. Lalo na yung mga nakatira po sa motel o sa hotel rather, ayan. Passcode, ayun po. So, thank you guys for listening po in our pre-instructions prior to your learning tasks. I hope so that you understand the discussions and the video is provided for you to browse it and watch it several times. And I'm going to post it on the FB page. So thank you everyone for listening and listening and learning in our lessons instructions. So be happy, be happy with positive attitudes always, and be matsaya. Happy listening. Good luck everyone.